All right, so now that we've had a quick review of how to write code that involves loops and branching statements or conditional statements like if statements, let's go ahead and let's take a look at some new stuff. And I'm going to call this Boolean Logic. It's called Boolean Logic because there was a guy named Boole, B-O-O-L-E, and he is kind of the one who was responsible for coming up with this logic, or at least taking a way of using logic that had been known and providing some notation to go with it. So anyways, this not statement here is actually part of Boolean logic. We can take something that's true and make it false by saying not true, or we can take something that's false and make it true by saying not false. So anyways, we're going to look at that again more when we look at probability. The other thing is about Boolean logic is we can do things like OR. So for example, we can check to see if the box that we got has a 3 or if the box that we got has a 4. And that is known as Boolean logic. So we can check to see whether we got a 3 or a 4. And then we can say yippee yahoo. Now, I need to make a quick check here. When we were last checking our prizes, if we got a 0 or a 1, we said we got a LeBron. So I'm going to go back to that and say if box equal equals 0 or box equal equals 1, then we'll say, hey, we got a LeBron. Yay! Okay, so we'll change that around a little bit. Otherwise, the code that we used in the review is still usable. Okay, now what this should do is anytime we get a 0 or a 1 as a box, either one, we should say, hey, we can stop. We got the LeBron. So this is kind of interesting. What I'm doing now is I'm making it so this is not the original simulation we looked at. This is a simpler version of it. Here, one complete trial is we keep buying boxes until we get one LeBron. That's different than the simulation we looked at, where one complete trial was to get a complete set of sports cards, including LeBron, Danica, and Serena. So anyways, I'm going to go ahead and hit run. And what we can see is we had to buy 4 boxes of cereal to complete one trial, and the outcome of that one trial, what we were looking for, was to get a box with a LeBron sports card in it. So I'm going to go ahead and hit run again. And that time we only had to buy 1 box of cereal, yay. But when I do it again and again, eventually we will find that maybe we have to buy more boxes. So I'm going to run this a few times. Is there ever a time where we have to buy like 10 boxes? Oh, look at that, 15 boxes, yay, cool. Okay, all right, so anyways, the code's running. And the thing that I love about this, and I hope that you're getting this idea too, is that once you write the code and it works, the computer does all the work for you, and it can do a lot more work than you can in a much shorter period of time. But you do have to invest the initial amount of time in learning how to write the computer code. Okay, so this is the Boolean OR. Now, today I want to introduce you to another Boolean idea, which is the AND. Now, why do we care about the AND? Well, the problem is that as we go through and we write the code for the simulation, if we want to do the complete simulation and find out how long it takes to get a complete set, then we have to have a way of determining whether or not we already got a LeBron, and if we do, then well, hold on, let me get my facts straight. Thank you. Just had to clarify my thoughts. So one of the tricks here is we have to figure out a way to to make a note that we got a LeBron and not count it multiple times as we buy more and more boxes of cereal. What we want to do is we want to have a way to indicate to the computer program that we got a LeBron, and then we got a Serena, and then we got a Danica. And remember, we could get them in any order, and we could get multiples of each. But our goal is, as soon as we know that we have one of each, we stop. So in order to do that, we're going to need another kind of Boolean logic, and that'll be the AND. So let me see if I can give you a quick demo of how we're going to use AND. what we're going to do is this. We are going to use something that computer programmers call a flag. And the flag is kind of like your mailbox. If you guys have one of those mailboxes that has one of those flags on the side, I don't know if you're even aware of it, but in the old days, our mailboxes had a flag on the side. And if the flag was up, well, hold on, let me make sure I got this. So in the old days, when people had mailboxes that looked like this, they would have a little flag on the side. And if the flag was up, it would tell your postal carrier that you had mail that needed to be picked up. So even if the postal carrier, the mail delivery person, even if they had no mail to give to you, if the flag was up, they would stop and make sure that they pulled the mail out of your box. If the flag was down and they had no mail for you, they could skip your mailbox. Interesting system, huh? Anyways, in programming, we use this idea of the flag to help us understand whether or not something is true at the moment or not. So anyways, what we're going to do is we're going to create a little LeBron flag. And our LeBron flag is going to look something like this. Where I'm going to call it, let's see here. I'm going to call it card L. In other words, I'm naming the flag card L because this flag will tell us whether we have a sports card with LeBron on it. So card L, I'm going to set equal to 1 when we get a box that's a 0 or a 1. Now this number 1 has nothing to do with this 0 or this 1. This 0 and this 1 for the boxes just means that we're going to get a LeBron. In other words, we're getting 0 and 1 represents LeBron, 2, 3, and 4 represents Danica. So this one down here just tells us whether we got a LeBron card or not. So that has a different meaning than this one over here. I apologize if that's confusing. Hopefully it'll make more sense when we include the Danica and the Serena. Anyways, so that will tell us, hey, we got a LeBron card. So, and once we know we have a LeBron card, then we can say, aha, I need to keep buying boxes of cereal until I get a Danica and Serena, and then I'll be done. Okay, now there is a little bit of a problem. I have to initially say that we don't have a LeBron card. So at the beginning, I'll say LeBron card equals 0, and we'll only set it to 1 if we get a LeBron card. Now, here's where the Boolean logic for the AND comes in. What we want to do is we don't want to keep trying to track LeBron cards if we already know we got one. As soon as we know we got one, we don't need to keep counting them. So what we're going to do is this. I'm going to go ahead and say box equals 0 or box equals 1. This must be true in order for us to print that we got a LeBron card. But also, and the LeBron card must equal 0. Now, why must the LeBron card also equal 0? Because we're only going to print that we got a LeBron card once. We don't want to keep printing that we got a LeBron card over and over and over again. And again, I'm talking about when we get further along and we're doing the entire program that includes LeBron, Serena, and Danica. So anyways, if we set the flag to 1 when we get a LeBron card, if we set the flag to 0 when we have no LeBron card, and if we check that we have no LeBron card before saying we have one, that if we put all those three things together, now we have a system that we can use to track to see whether or not we've got all the cards that we desire. I understand that the program's becoming a bit more complicated, but don't stress out. In the end, I'm going to make sure that you have everything you need to get this. So anyways, we've got our Boolean logic OR, we've got our Boolean logic AND hopefully this code works. So I'm kind of curious. I guess I'm going to go ahead and run it. I don't think it'll be much different. The code really only makes a difference when we throw in the Danica and the Serena. So I'm going to go ahead and hit run, and let's just see if the code runs any differently. No, it's still doing all the same stuff. So right now the code doesn't do anything differently. But if I add in the Danica and the Serena, it will be really important. So let me go ahead and try that. Okay, so if we're going to add in the Danica and the Serena, I'm going to have to get rid of this done equals 1, because we're not going to be done until we get at least the LeBron and the Danica. So I'm going to go ahead and add a statement to the if. We're going to make this an elif, and we're going to check to see whether the box equals 2 or 3 or 4. Now I am going to give you again a little bit more advanced stuff, and by the way, one of you reminded me about this, that there's another way to check. I'm going to say if box is greater than or equal to 2, or box is less than or equal to 4. Ooh, actually, this is an excellent use for an and, because the or doesn't work here. And by the way, this is not a bad refresher for you guys who learned something called compound inequalities years ago in Algebra 1 and maybe Algebra 2 class. This is a compound inequality, and in order for it to work, I'm going to have to make this an and. I want the value of box to be greater than or equal to 2 and less than or equal to 4 in order to say that I've got a Danica. So we'll go ahead and say, okay, now we can say if the value of box is between 2 and 4, then we can say print, and we'll put a Danica in there. And then let's see here, and then we can say card D equals 1, because now we'll be able to take credit for having a Danica card. And then we will say let's start off the Danica card equal to 0 before we ever get one. Oh, and I am going to throw something super tricky in here, and I'm going to say if we get the Danica card, card D will not equal 1. I'm going to say card D will equal 2, and I have a super fancy reason for that. And I don't know that I have a great explanation for you right now. But this is based on some years of programming and a little bit of tricky math. I'll try to put it together for you. Anyways, so now we can check to see whether we have a LeBron and a Danica. The only thing is we're saying that card D equals 2 when we get the Danica card, and we're saying that card D equals 0 when we don't have it. We only want to set card D equal to 2 when we finally get the Danica card. So let's see here. So we're going to keep doing this as long. We're going to keep we will only say card D equals 2 when we get the Danica card. So I'm going to put an and card D must equal 0 in order for us to set card D equal to 2 and print Danica. Okay, sort of like what we did up here. So I'm throwing in some Boolean ands for you. That's where things get a little bit advanced here. Okay, so that will let us say we got the Danica. Yay. Okay, and as long as I'm on a roll, I think we're going to go ahead and throw the LeBron in here as well. So let's do it. So we're going to say elif card. So I'm sorry, we're going to throw the Serena in. Okay, this is interesting. Since we already know that since we've used these if statements and we either got a LeBron or we got a Danica, the only other option is that we must have a Serena. So if it's not one of these values and it's not one of these values, then it must be a Serena. But we only want to count the Serena one time. So we're gonna do this. We're gonna go ahead and check to see whether we got a Serena card. And the way we'll do that is, well, at this point, we will only go in here and notify the user that there's a Serena card if we didn't already do that. So here we go. So we're gonna indent after we get the else if, and then we go ahead and we say print Serena. Yay! So we got our Serena card. Now, at this point, we will then set the Serena card to equal to the flag that we got a Serena card equal to 4. Now, again, I'm setting the flag for the LeBron card to 1. the Danica card to 2 and the Serena card to 4 because of a little math trick that I know. So anyways, here's what we're going to do. So after we do all that, we are I think that's good enough. I think that'll do just about everything that I want. Oh, we still want to count, and we want to make sure we know what the count is. Did I throw away where I print the count? No, I have it up here. Now we want to count how many boxes of cereal we bought all total to get all 3. So I no longer want to print count inside of the LeBron if statement. So I'm going to go ahead and cut that line, and I'm going to go ahead and paste it down here. That's a Control X and then a Control V, or if you're on a Mac, it's a Command X and then a Command V. And so that will let me, let's see here. Oh, and as long as I'm at it, I want to throw in a little bit of troubleshooting for you folks. Again, a reminder, I just went and hit run, and when I did, I noticed I got this error message, and I wasn't sure why I got it, but I figured out eventually that the problem is that I'm checking to see what the value of card S is, but I never set card S equal to any value. Here it is set to some value inside the if statement, but I'm going to have to initialize card S Serena card flag equal to 0 at the beginning, just like I did for all the others. So I'm going to go ahead and hit run now, and then maybe I can see if I still have some other problems I can figure out. So I keep hitting run, and I keep running into an error there, and I discovered that I have another issue besides having to initialize the value for the Serena card flag. I forgot to put a colon here, so let's try that. So I'm going to go ahead and hit run, and now something's happening, but it looks to me like I'm in an infinite loop, so I'm still going to have to figure out how to stop this loop. So let me see what I can do. Oh, by the way, in the old days when you ran into an infinite loop, sometimes your computer would actually literally die. But fortunately at Trinket, I can just hit stop even when I'm in an infinite loop. Even so, we're going to try to avoid infinite loops if at all possible. So I'm going to go ahead and clear my console output, and I'm going to try to figure out why am I getting stuck in this infinite loop. And the problem is it's because I never set, I'm still doing this while not done, but I never set done equal to 1. Done is still equal to 0 the whole time. So I'm going to have to figure out how to set done equal to 1, and we're getting to that in just a second. So let's see here. I'm going to go ahead and print count when I'm done with, well, every single time I buy a box of cereal, I want to print count. The other thing is this. Here's where I do a little tricky computer math. I'm going to say sum equals card LeBron, the LeBron card flag, plus card Danica, plus card Serena, and that's going to get me some number. And well, it'll get me the result of adding together the 3 flag numbers, 1, 2, and 4. Now the thing is, remember, initially those guys are 0, 0, and 0. So what's going to happen is when I eventually get a LeBron, I'll have card L be 1 plus 0 plus 0. When I eventually get a Danica, it'll be 1 plus 2 plus 0. That's 3. When I eventually get a Serena, I'll have 1 plus 2 plus 4. That gets me 7. So what I'm going to do is I'm going to check to see if sum equal 7. And if I ever get that result, then voila, I have a complete set. So sum equals 7. And then we're going to go ahead and do the indent like we always do. Done equals 1. Now we can say the loop is done. And then I can print the actual count. So I guess I was a little premature in printing the count here. I don't really want to print the count there. What I'd like to do is after everything is all said and done, I'd like to print the count. So I think. So I'm going to go ahead and print the count at the end. Let's see here. Maybe I'll even do that inside the if statement for sum equals 7. So let's go ahead and run the code. Let's see what happens. Here we go. So we got we bought one box and got a Serena, bought another box and got a Danica, bought 3 boxes and finally got a LeBron. There was a total of 5 boxes that needed to be purchased. This code is actually looking like it's working, and that's pretty cool. So I'm going to go ahead and hit run. And that time we had to buy 10 boxes and hit run again, and 3 boxes and hit run again, 4 boxes. Okay, so we're getting pretty close to finishing up the total code that's needed for us to conduct this sports card simulation. What I'd like you guys to do is I'd like you to try to follow my logic and copy down the code that I've expressed here. I'm certainly hoping that you watch the entire video so that you can try to understand why the code is doing what it's doing. Because after we're done with this, I want to give you a problem where you write the code from scratch and not with me telling you every step of the way what to do. So your understanding is going to be important. Okay, so let's see here. I'll let you guys get caught up to me. Make sure you can write this code. Make sure you can run it. And then I'm going to ask you to prove that you did it.